This is Mahesh. In this session, we are going to see divisibility rules. Okay, let's get started. The thing why we need to know divisibility rule is because if there is sums like the numbers, for example, 1, 3, 5, 7, dot, 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 5, 3, 6, 2 is divisible by 8 or something. If the question is like that, we don't have number in between, digits in between the number, which means we can't able to find whether that is divisible by 8 or not. So that is why we need to know certain rules to find out the values clearly. Okay. So divisibility rules. So you know that every number is divisible by 1. So from 2 to 19 totally. So 18 numbers we are going to see the rules for those 18 numbers. Okay. Let's get started. The first thing you all know that what is rule for 2? You know that. So if a number is divisible by 2 means what? What is the meaning? That number is even number. Or else one more thing you have to know. The last digit alone, if you want last digit alone, you have to take that digit is divisible by 2 means then the number is divisible by 2. So the rule for 2 is number should be even or the last digit should be divisible by 2. That's it. So for example, if you take any number except odd numbers, everything is divisible by 2. Okay. Next, rule 3. So divisibility rule for 3 is sum of the digits should be divisible by 3. For example, given that 372 is 372 divisible by 3. Yeah. When you add 3 plus 7 plus 2, you will get 12. 12 is divisible by 3. So 372 is divisible by 3. Sum of the digits. You have to add the digits. Add all the digits in the number. How big the number is. No issues. Just add all the digits and then that sum should be divisible by 3. If that sum is divisible by 3, then the whole number is divisible by 3. Okay. Next, divisibility rule for 4. If there is a number which has 100 digits, means how will you find whether that number is divisible by 4 or not? Just you need the last 2 digits of that number. Last 2 digits should be divisible by 4. If the number is very big, no issues. When the question is about divisible by 4, you just need last 2 digits. If last 2 digits divisible by 4, then the number is divisible by 4. Example here, 49532. So 49,532. Whether 49,532 divisible by 4? If you check, so 32 is divisible by 4. So 49,532 is also divisible by 4. So you need last 2 digits alone. Okay, next. Divisibility rule 5. Last digit should be 0 or 5. We know that. If a number is divisible by 5, we know that, right? Last digit should be 0 or 5. Done. Examples given here. If last digit is not 5 or 0, then that's not divisible by 5. If it is last digit is 0, divisible, and last digit 5 means divisible. Next, number should be divisible by both 2 and 3. So, if the question is about divisibility rule 6. If a number given and then if they are asking you whether the number is divisible by 6, then you have to check 2 rules, 2 and 3. Why? Because 6 can be written in prime factorization form 2 into 3. Okay? 2 into 3 is 6. If you check 2 and 3, if both satisfies, then that number is divisible by 6 also. Example given here. So 73,260. When you check, the last digit is 0 and then the number is even, so it's divisible by 2. And when you add all the digits, you are getting 18. That is divisible by 3. So divisible by 2 as well as divisible by 3. So that number is divisible by 6. Next, this is the one different kind that you may not know this. So this kind we have 4 numbers. For 7 and 13, 17 and 19, we are going to use same method but with different numbers. Here what you have to do is for 7, last digit should be multiplied by 5 and it should be added to previous digits. Repeat this process until you get 2-digit number. Listen, if there is a number in that number there is a last digit, right? That last digit should be multiplied by 5. You will get a value. That value should be added to the previous digits. So listen here. 73,514, 7351. Sorry. 7351 4 into 5. So that last digit into 5, 20. I'm adding that 20 here. I'm getting 7371. I'm now multiplying 1 into 5. I'm adding that 5 to the 737. So I'm getting 742. And 2 into 5, I'm getting 10. 74 plus 10, 84. 84. When you get 2-digit number, you know the table for 7, right? So 84 is divisible by 7. So obviously 73,514 is divisible by 7. That's it. The same thing we are going to use in 4 numbers: 7, 13, 17 and 19. Okay. The thing is, you have number and then you have to take the last digit and multiply it with 5. That number should be, the value should be added to this number, previous digits. So you have to remove this digit and the previous digit plus 4 into 5, 20. That process should be done until you get 2 digits, because we know multiples of 7 in 2 digits. That's why. Okay, next question. So next thing, divisibility rule 8. Last 3 digits should be divisible by 8. When the rule is about 8, you have to check last 3 digits. If the last 3 digits are divisible by 8, then the whole number is divisible by 8. Here, listen. 3, 4, 5, 6, 7, 7, 6, 8 is the question. Whether this number is divisible by 8 or not is the question. Now, you need only last 3 digits. In between digits and all, you don't require. You require last 3 digits. 768. 768 divisible by 8 means the whole number is divisible by 8. Yeah, 768 is divisible by 8. Because I know that when you cancel this, so 9 times of 8 is 72, remaining 4, and 48, 6 times of 8 is there. So, divisible by 8. Divisibility rule of 8 is very simple. Last 3 digits alone you require to find out whether the number is divisible by 8 or not. And then 9. So the rule 3 is same as 9, but here some of the digits should be divisible by 9. So here some of the digits should be divisible by 3. Here in 9 some of the digits should be divisible by 9. Here I have a number 3,12,651 divided by 9. Whether this is divisible or not? Yes. So if you add all the values, you are getting 18. 18 is divisible by 9. So that number is divisible by 9. Okay, 10. The digit 10, we know that last digit should be 0. If there is a digit with last 0, then that is divisible by 10, because it could cancel 0, 0. That's why. Here it ends with 5, which is not divisible. Here it ends with 0, so it's divisible. So next 11. So you know that 11th rule. So sum of odd quotient digits minus sum of even quotient digits should be 0 or multiples of 11. Nothing but you have a number. For example, I will take 121. Simple number. 121. What are the odd quotient numbers? First and third. 1 and 1. In 121, first and third are odd quotient numbers. Second is even quotient number. So 1 and 1 plus 1, 2 you will get. And then even quotient digit is 2. So 2 minus 2, 0. So definitely 121 is divisible by 11. The same thing we have to use here. Sum of odd quotient digits minus sum of even quotient digits should be 0 or multiples of 11. So here I have taken a big number 3, 2, 5, 6, 7, 8, 6, 5. Whether this number divisible by 11 or not is the question. So if there is the number like this, you have to take odd quotient numbers and then sum them up. So 3, 5, 7, 6. These are all odd quotient numbers. I have summed it. And minus. So 2, 6, 8 and 5. Even quotient numbers. If you subtract these two, you will get a difference. That difference should be 0 or multiples of 11. Whether it is minus or plus doesn't matter. The difference should be in multiples of 11 or 0. Here 21 minus 21. So you are getting 0. So this number is divisible by 11. Let's move on to the rule 12. So this number should be divisible by both two numbers, 3 and 4. Whenever you have numbers like this, so you can take two values. For example, So 15 and example I have taken 15,732 divided by 12. Here you have to take 3 and 4 because 12 is can be splitted into 3 into 4, right? You know the rule for 3. Sum of the digits should be divisible by 3. And then you know the rule for 4. Last two digits should be divisible by 4. When you take these last two digits, 32 is divisible by 4. And then sum of the digits 1 plus 5 plus 7 plus 3 plus 2. So totally 6 plus 7, 13, 13 plus 3, 16, 16 plus 2, 18. 18 is divisible by 3. So both 4 and 3 are satisfied. So this number is divisible by 12. And then 13, as I already told you, that same rule what we have used here will be used here, but the number is different. Here last digit should be multiplied by 4 and it should be added to previous digits, repeat until you get 2 digits. The same method, but instead of 5 I am using 4 for the 13. Okay, so I have taken a number 13169. Okay, 9 into 4, last digit into 4, I am getting 36. I am adding these two, I am getting 1352. Now again I have to multiply 2 into 4, last digit into 4, I am getting 8. So when I add these two, 143, you will get 143. Again I am multiplying the last digit with 4. So 12, 14 and 12, 26. 26 is divisible by 13. I know that. When it comes to 2 digits, I could know that. So answer is divisible. 13,169 is divisible by 13. Done. Next 14. 14 should be divisible by 2 and 7. We can make 2 and 7. So 2 is even number and 7 is, you know the rule for 7 as well as. So if you substitute those two rules, then that is divisible by 14. I have taken the same number 73,514 there. So which is a even number. So which is divisible by 2 and which is divisible by 7. I know from here. So that's why this is divisible by 14. And then rule 15 should be divisible by both 3 and 5. So I can split 15 into 3 and 5. So which means both the command should be satisfied. Both the rules should be satisfied. 3 is sum of the digits should be divisible, and 5 is nothing but the last digit should be 5 or 0. Done. So here 5 last digit is 5, so it is divisible by 5. And sum of the digits is 21, so which is divisible by 3. So answer is yes. This number is divisible by 15. And when it comes to 16, last 4 digits should be divisible by 16. So here listen, there is a pattern. When you go for 2, last digit should be divisible by 2. When you go for 4, last 2 digits should be divisible by 4. And when you go for 8, last 3 digits should be divisible by 8. And then when you go for 16, last 4 digits should be divisible by 16, which means 2 power 4 means you need only last 4 digits. If the question is about 2 power 5, 2 power 5 is what? 32. Even 32, for the rule 32, we know that last 5 digits is enough to find whether the number is divisible by 32 or not. If it is 64, then you need last 6 digits. That's it. Okay, and so on. So that's all. The number is given 3216 and 1632. So I need only last 4 digits. I know that last 4 digits is divisible by 16. So the answer is divisible by 16. And then 17, the same rule we have been using for 7 and 13. Last digit should be multiplied by minus 5 here. For 7, it's plus 5. For 17, it's minus 5. So, and it should be added to the previous digit. Repeat until you get 2 digits. So, you have to repeat the process until you get 2 digits. So, I have taken 19,108. 8 into minus 5, I will get minus 40. So, when I subtract 40, I am getting 1870. 0 into minus 5, again 0. 187. 187, the last digit into minus 5, I will get minus 35. 18 minus 35 will give me minus 17. Whether it is minus or not doesn't matter. Minus 17 is divisible by 17. That's it. That's what we require. Okay? Done. Next, 18 rule should be divisible by 2 and 9. So 2, if you know the rule for 2 and 9, then that's all for 18. 19, last digit should be multiplied by 2 and it should be added to the previous digits. Repeat until you get the two digits. The same thing we did for 7 and 13 and 17 and 19. The numbers are different. For 7 you have to use 5. For 13 you have to use 4. And for 17 you have to use minus 5. For 19 you have to use 2. Last digit should be multiplied and then should be added to the previous digit. That process should be repeated until you get 2-digit numbers. When you get 2-digit number, here I have commit the process and I got 57. 57 is divisible by 19, so this is divisible by 19. If you know these rules, you could form rules for the others also. If, for example, if the question is about divisible by 35, how will you make 35? 7, 5, no. 7 into 5 is 35. If the question is about finding whether the number is divisible by 35, then you can use both the rules, 5 and 7. So if it is not satisfying 5 means that number is not divisible by 35, we could say. In 24, if you take 24, 3 and 8. 3 and 8 is 24. At the same time, why can't we take, for example, for 16, we can take 4, 4, right? 4 into 4, right? Which means that is not the case here. Here, if you are taking two numbers, means the two numbers should not have any common factor. Here, listen. Here we have taken 2 and 3. 2 and 3 doesn't have any common factor. At the same time, when it comes to 12, I have taken 3 and 4. 3 and 4 doesn't have any common factor. I didn't take 2 and 6. Because for 12, I didn't take 2 and 6 because 2 and 6 has common factor. Here 3 and 4 doesn't have common factor. 2 and 7 doesn't have common factor. 3 and 5 doesn't have common factor. Like that 2 and 9 doesn't have common factor. If you take 6 and 3 that has common factor, you should not take. For the 24 also, you should not take 2 and 12 because that has common factor. For 24, you can take 3 and 8 because that doesn't have any common factor. If you are, for example, 56, if the rule for 56, you know the rule for 56, which is nothing but 8 into 7. So 8 and 7 doesn't have any common factor. For 38, rule for 38, which is nothing but 2 into 19. So you know the rule for 2 as well as for 19, then 38 is over. Likewise, you can form rules by yourself. Okay, that's all the divisibility rule.